is me standing next to one of the most impressive satellites of its time. With this, I'll be the first squirrel to go to space. Is what I'd say if this weren't just a model of the real thing.
Why do you want to go into space, Sparky?
All my squirrel friends around the world are telling me about how hard it is to stay safe with all these disasters happening. My Canadian squirrels live close to the wildfires, and my Kentucky squirrels have had their homes destroyed by floods, all of which didn't happen at this scale before. Isn't there anything I can do?
You know, there's another way you can help that doesn't involve sending you into space.
The SPARC. This is the SPARC. Now, before Amanda explains how it works, I want to take a moment to emphasize how cool this trailer is. These University of Wisconsin SSEC scientists needed a way to get atmospheric data from faraway places. Problem is, their machines are super heavy and expensive. The solution? Put them on wheels and build an awesome trailer that has everything you need and can take you anywhere. Right, Amanda?
Of course, the SPARC is literally a research laboratory on wheels. It was designed to make data collection easier in hard-to-reach areas and places with weather worth researching. When we look up at the sky, we see the blue sky and maybe some clouds. And what's special about the SPARC is that it can use an ARRI to see invisible molecules by using what's known as infrared energy. This is the ARRI, and it can take a clear sky like this and make a map showing the temperature and humidity at various levels and making a map for the sky. For example, if we look at the sky with our eyes, we might see this. But with the ARRI, it sees this. It sort of reminds me of that one movie. The SPARC can also calculate wind speed and direction using a Doppler lidar by sending a light particle into the air and measuring the time it takes for it to come back. And then there's the HSRL, which also sends a laser into the sky, but it's big and green. Using that laser beam, we are then able to see what the sky looks like if we cut it in half from space. This is how we take cross-sections of clouds and pollution.
When we put it all together, this is what it looks like. The white lines tell you the wind speed and direction, while the background shows temperature and molecules. Based on this and hundreds of thousands of data just like this, we can do more than just understand rain. We can understand all of this. This is one entire system, and even the sunny days affect rainy ones. And while a sunny day might not be too interesting, these scientists like to drive out into an open field where they go storm chasing. Here's a fun little experiment you can try at home without getting struck by lightning. Take a glass jar, a glass bottle, a rubber band, and some food dye. Clean the glass jar and bottle and dry them completely. Afterward, fill the jar with colored water until the water level is above the lip of the glass bottle by about 3 centimeters. Wrap the rubber band around the jar where the water level is, and you're done. You've just created a homemade barometer. Just place this outside in the shade and watch as the water level changes. If it drops below the rubber band, it means it might start raining. This uses the concept of atmospheric pressure, and when molecules in the air cool down, they slow down. The problem is, some molecules don't slow down as quickly as others. Carbon dioxide, for example, is one of them. Because of pollution, there's so much of it floating around in our atmosphere, and since the sun is constantly shining on us, it keeps absorbing that energy, which causes the Earth to grow hotter and hotter every day. We know this because of the data from instruments much like the ones on the SPARC. These very molecules and others are the cause of more unpredictable severe weather storms, droughts, floods, and wildfires. In Arizona, a monsoon that comes around every summer to cool down the state has been delayed, and now Arizona is experiencing a record-high heat wave. Even sea life is affected too. Coral needs to be rescued out of the ocean since the water is too hot and is being bleached. Land, air, and ocean life are being threatened as we speak. But there are people who are trying to directly help address these issues. There are many areas in the world where atmospheric research has not reached and places that have not been measured. With dangerous floods and severe storms on the rise, scientists are going out into the field to create better detection systems. Our solution is the SPARC and its younger sibling, the SPARClet, which can actually travel anywhere on the globe. Here it is being deployed in Barbados, an island that may not look as beautiful as it does now if the climate problem isn't addressed. We aren't the only ones actively fighting either. We work with the National Science Foundation, NASA, the Department of Energy, and the National Weather Service in a collective effort to help make the world safer, and the SPARCs are just a part of this big mission. Anything affects everything, so it's important for these scientists to visit locations all around the world. Atmospheric scientists and meteorologists are working around the world to help keep people safe from severe weather and natural disasters. Their research helps improve weather forecasts, understand where to build a safe home, and helps farmers grow and protect their crops. To all of you aspiring scientists out there, we hope that you'll soar high and reach destinations you've never been before. Just like a weather balloon, keep on going until you're on top of the world.